हेलो। हेलो बच्चों। चलिए, हाँ भाई बच्चों, आवाज आ रही है ना? कैसे हैं? आज 2 घंटा पढ़ाई करेंगे, फिर आधा 1 घंटा बात करेंगे। कैसी है जनता? 2 घंटा पढ़ाई करेंगे, 2 ढाई घंटा पढ़ाई करेंगे और फिर बात करेंगे। सो हाउ यू गाइस? इज एवरीबडी ऑल राइट? लेट्स स्विच टू इंग्लिश। So last time we defined two equations and sort of classified them as small pair and big pair, right? So the small pair was this one. DPP will come in the description as well as in the update section of any straight lines course of Unacademy, as well as in the description of this lecture. So this is small pair and this is big pair. So there were some conditions. So first thing there was that we noted was always a pair of straight line. Do you remember? Always a pair of straight line. What about this one? It is pair of straight line when what happens? Tell me. When what happens? When what happens? Tell me. Tell me. It is pair of straight line when? Yeah, tell me. Perfect. Delta is equal to 0. This looks better. Okay. What about this? What is M1 plus M2 here? M1, M2 here, and tan theta here. Same. Both are same. Write it down. This is minus 2h upon b. This is a upon b twice root h square minus ab upon a plus b. This is minus 2h upon b. This is a upon b. This is 2 root h square minus ab upon a plus b. These two things are same for both of them. Has everybody noted till here? Has everybody noted till here? Please share the video to your friends. Anybody like the session. Now, what happens when I'll take it to the next page because there is no place here. So I am taking it to the next page now. We'll again write small pair, big pair. This is ax square plus 2hxy plus by square equal to 0. This is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Now, the next thing that we want to learn is what happens when a plus b is equal to 0. What happens? Perpendicular pair of straight line. Okay. And what happens when a plus b is equal to 0 here? Actually, nothing happens. Delta equal to 0 along with a plus b equal to 0. This ensures it's a perpendicular pair of straight line. Now, this big pair is surely a 2-degree equation. It is a 2-degree equation, and even this should be a 2-degree. Why should we write 2-degree in the bracket? Because we are not talking about case when a, h, and b all of them become 0 and every analysis becomes senseless. Because imagine if a, h, and b all three of them become 0, it is not even a 2-degree equation. Then what are we doing here? So we assume that it's a 2-degree. That means all of them are not 0. So it is surely a 2-degree equation. Then only these results are valid. Okay. Now what happens when h square is equal to AB? What happens here? What happens here? This is coincident. Coincident pairs. I don't think so. This is the last lecture. This is second last lecture. There will be a small one more lecture. I will post about it very soon. There might be one more lecture. Let us see. What happens if h square is equal to AB here? What happens if h square is equal to AB here? Here you cannot claim that it is surely a perpendicular pair of straight lines. You can't claim that. There are two possibilities that arise. There are two possibilities that arise. H square equal to AB and delta equal to 0. They do not ensure that it's a coincident pair of straight lines. Because here you know that their point of intersection is at origin. Here we don't know where is the point of intersection. Here you will have two cases. Here you will have two cases. What are those two cases? One will be either coincident or parallel. There will be two cases here. Now, how will you check when this becomes coincident? How will you check? What is the condition? How to check that it becomes coincident pair of straight lines? How to check? So when will it be coincident? When it will be parallel? How to check? Think. Beautiful method we have. Should I tell you how to check? Should I tell you how to check? Yes, class. Should I tell you how to check? Yeah, how will you check? Let me tell you how will you check. See, it's very easy. Look at this equation. Look at this. Huh. Agreed. You can say distance between the lines is 0, then it's coincident. But how to find distance? It is again that chicken and egg story. To get a chicken, you need egg. To get an egg, you need chicken. So there is one more way. I'll show you. Put y equal to 0. Now, if we put y equal to 0 here, you are trying to find point of intersection with x-axis. You are trying to find point of intersection with x-axis. But if it is coincident, if it is coincident, how many point of intersection should it have with x-axis? How many? How many should it have? Yes, tell me. If they are two separate lines, then you will have separate points of intersection. But if they are coincident, you will have two equal point of intersection, right? So what should happen here about this quadratic? What should happen about this quadratic? D should be 0. So 4g square minus 4ac should be equal to 0. So g square should be equal to ac. And note that this should be applicable for y-axis also. This should be applicable for y-axis also. It shouldn't be the case that it is having only one point of intersection with the x-axis, but for y-axis it is having two. It should be applicable for y-axis also. So we will apply similar thing for y-axis. Put x equal to 0 now. No, f square is equal to bc. So it should have repeated point of intersection. That means the same point of intersection with both x-axis as well as y-axis. So the condition for coincident is g square equal to ac and f square equal to bc. That is the condition. F square equal to bc. That is the condition for coincident. Is that okay, class? Is that okay? Is everybody comfortable till here? Relax, have patience, ask your doubt, don't worry. Yes, Sanjay Nandi is asking why should it happen. Sanjay, is it clear now? Sameep, in that scenario, we will say both the roots have become infinity and yet they are equal. I'll show you some examples, don't worry. In those cases also it will work. And what about parallel? Parallel, that means either of these conditions fails. Either g square is not equal to ac or f square is not equal to bc. One of them fails. Yes, Aditya. One of them fails. Both fails, that is even more wonderful. But yes, Sameep, what is your doubt? You asked why. I am not able to guess which part you are asking why. Note that this is and. This is and this is or. That means either one of them is okay. This is and. That means both must be true. Sameep, which part are you asking? You just asked why. I am not able to guess which part are you asking. You'll have to type. Yes, this is almost like a quadratic chapter. Pair of straight lines is almost like a quadratic chapter. That is why we should study it, because if the question comes, there will be a lot of janta. What will they do? They'll say pair of straight lines we will not study because it's not there. But understand that all concepts of pair of straight line are just concepts from quadratic. So JEE can still ask them. No, Abhishek, no, 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 no. It doesn't happen. I'll give you example. Look at this. Look at this straight line. Sameep, type again then. Look at this straight line. This pair of straight line. This is a 2-degree equation. This is a 2-degree equation. Similarly, look at this. Huh. This is a 2-degree equation. Now see, you have G. The mistake, Abhishek, the thing that you asked, most of the books have done this mistake. Now see, G is equal to -2, A is 1, and C is 3. F is equal to 0, B is equal to 0, and C is 3. So observe, F square is equal to BC. Yes, but it still does not ensure that G square is equal to AC. You can't say that both of them will coexist. But G square is not equal to AC. So what happens here? You get two lines, x equal to 1 and x equal to 3. X equal to 1 and x equal to 3. You will get two parallel lines. So we need to check both of them. Yeah, this is that case, Sameep. This is that case, Sameep. You have to check both of them. Then only it becomes coincident. If only one of them is true, that doesn't mean that it is coincident. There are cases when one of them is true, the other one is not true. Other part is not true. Is it clear, class? Now look at this one. Look at this one. Most of the books have done this error. They feel that only one of them is enough. That is not true. Look at this now. Here G is -2, A is 1, and C is 4. F is 0, B is 0, and C is 4. Observe that G square is equal to AC. Yes, F square is equal to BC. Both are true. Hence, when you will factorize, what will happen? You will get two coincident lines, x equal to 2. So for coincidence, both must be true. And obviously, if this is intersection, those of you who have studied PNC know that A intersection B will have complement as A dash U. I don't think there is place there. If this is A intersection B, then this part can be written as A dash union B dash. So either A fails or B fails. So that is the whole logic. If this is A intersection B, and means intersection. Either or means union. Just copy this page. I'll turn the page up. Don't worry. Has everybody written this? Has everybody written it? Most of the books do this, that for coincident apply G square equal to AC. Note that only G square equal to AC is not enough. Both of them should be true. And most of the videos on YouTube will also do this, but not this one. Because this is us. I gave you examples. See? Clear-cut examples. No, nothing, nothing. It is just an arrow. Nothing is written behind my 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 photograph. It is just an arrow. It is just this one. This, like this. Is that okay? Now again, write small pair and big pair. This is again angle will be 0. If the lines are parallel or coincident, angle has to be 0. Now, what again? Now see, what happens when h square is greater than equal to AB. We get what? Real lines. Do you remember? Class, please like the video. What happens if h square is greater than AB? It is real and distinct. What happens when h square is less than AB? Non-real. Everybody remembers? How to ensure that pair of straight lines is real here? Now this is really tough. But of course, if you will study from random sources, it looks easy, but it is really tough. It is really tough to ensure that this pair of straight lines is real. Uh, Now see, it's not easy. People think that it is very easy. We have studied in many books. We have studied in R.D. Sharma. We have studied in Singh's book. We have studied in that book, that book. They have done a blunder, big blunder, most of them. Uh, this does not ensure does not ensure that pair of straight line is real. This does not ensure. Uh, I'll give you an example. I'll give you an example. I'll give you an example. This is what most of the books write. Most books plus teachers, but that's not true, unfortunately. ये error कर दी. Okay? I'll show you why this thing happens. Look at this example. Huh? X square plus 4xy plus 4y square plus 2x plus y, 2x plus 2y plus 3 equal to 0. Just a second. I'll give you another example. Wait, it will take me some time to create, but we can create. Just a second. Y square. Okay, look at this now. Very simple. I deliberately changed it so that you have less calculations. Now see for this. What is h? H is 2, A is 1, B is 4, F is 0, G is 0, C is also 1. Right? So let's find out delta. So delta is A, B, C, which is 4, plus 2FGH 0, minus AF square 0, minus BG square 0, minus CH square. So delta comes out to be 0. H square comes out to be 4. AB also comes out to be 4. So it satisfies H square equal to AB and delta is equal to 0. Satisfied. Now try to sketch it. Now try to sketch it. You will not be able to sketch it. This is a pair of straight line for sure, but not real one. Why? I'll show you why. This is this equation. No real point will satisfy this. Perfect square plus 1 equal to 0, no real point will satisfy. Now some people who might have studied pair of straight lines in the past might be stunned. They never thought of it like that. So it's non-real. The lines that it will actually draw are these x plus 2y equal to iota and x plus 2y equal to minus iota. These are the lines it will draw. And you will never find these lines on the real plane, even complex plane. Some people must have thought the whole childhood was a lie. They kept on applying this in their childhood and said amazing, amazing on. But this is not true. So just copy it down. Just copy it down. Trust me, I have stopped myself from giving you a lot of things in this chapter that will show you how wrong other sources have been dealing this chapter. Why? Because I feel it's YouTube and you don't need that much for JEE, but still we'll go where JEE can go. Okay, now see. So it does not ensure. So what to do? H square greater than AB, delta equal to 0 ensures. So now I'll just write down some points. See if you can make sense of it. H square greater than AB, delta equal to 0 ensures real and distinct. Correct. H square equal to AB, delta equal to 0 ensures this is the corrupt case actually. Because of this case, sometimes ensures the lines are either parallel or coincident. But not necessarily real. So you will have to check, but not necessarily real. And this becomes really tough to gauge. And this becomes really tough. Where to, how to check this and that. So hence, good books avoid this question of real and non-real for a big pair. What do the good books do? They avoid this question of real versus non-real for big pair. For small pair, they are very happy. For small pair, everything is straightforward and they are very happy. But for big pair, there is actually some these kind of things happen. There is no surety when h square is equal to AB. There is no surety. Yes, h square greater than AB has surety. This part is sure that it is real and distinct. But again, there is an issue. But again, there is an issue. You cannot say real and distinct. This is the only case. Even when the lines are parallel and real, they are real and distinct. So even real and distinct case is not completely covered by this. Some people think that real and distinct case is completely covered by this. Not true. Even parallel lines, when they are real and distinct. So there is a lot of much here. So good books, JEE try to skip that. They don't look at it. If you want, I can give you conditions when it will be real, when it will be non-real, but it will be very, you will be very worried how to remember it. Do you want? I can give you. Let's avoid it for the time being. Let us learn something, some new other things. Let us learn something more important. Then we'll come back to this. Don't worry. Now see this one. Okay. So if let's say big pair, if this big pair, I am deliberately not giving you that part. If you want, I will give you, but then the whole lecture will go into that. And trust me, then people will cut down parts of this video and show what people have been writing wrong in the books about this part. I'm just not doing it because I feel that the lecture should benefit you more than me. Okay, so that is why I'm avoiding that. I'm saying it's not needed because if the question comes, it will be too complicated. So mostly it will not come. When the chapter itself is a small chapter, so in a small chapter, certain portion, and then you go into that all that detail, it's not needed. Okay, I'm stopping myself. I want to show off. I want to flex, but I'm stopping myself. Hmm. Okay. There is one more difference between big pair and small pair. What is that difference? The small pair has every term of degree 2. It has every term of degree 2. What is this name? Non-copyright music. Every term of 2 degree. So it is homogeneous. This one is not homogeneous because you will find there are 2 degree as well as 1 degree. This is non-homogeneous. Can you see this difference? Yeah, that is why Navneet I have stopped it. Most probably NTA will also do wrong in this if the question comes. And there will always be that issue that you are wrong, this and wrong, and then court case will happen, this and that, and I feel not required. Okay. Has everybody understood this part? This is non-homogeneous. This is every term of degree 2 to homogeneous of second degree. Correct? Okay. Also, there is one more difference between small pair and big pair. The small pair has its center or point of intersection at origin. The small pair has center or point of intersection at origin, right? But not for big pair. Big pair does not have point of intersection or center at origin. This is also called center. This point of intersection is also called center. This might be some point alpha comma beta, some point. How will you find alpha and beta? How to find alpha and beta? That's a valid question. You might need to find that point where they are forming. Yes, Nishu. Yes, 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 yes. Homogeneous means every term has same degree. So it has every term having 2 degrees, right? 2, 1 plus 1, 2, 2. How do you find alpha and beta? There is one method. Method 1. Separate separate the lines, then solve. Good method, but lengthy, right? In fact, this is the uh, mathematically better method. Now there is another method. We will not do the proof of that method, but we will learn that method today. The method 2 is just copy it, copy it. Okay, so method two is finding center. Now every 2 degree curve except parabola has a center. So circle has a center, ellipse has a center, hyperbola has a center, and of course pair of straight line also has a center. They all have a center. How is center defined? We'll talk about that in conics, not right now. And all of these equations, parabola does not have a center. You can say parabola is crying in the corner. Parabola does not have a center. No center. So all these equations are 2-degree equations. All these equations are 2-degree equations. So there is a method to find their center. There is a trick to find their center. And of course, if we apply the same method for pair of straight line, you will get you will get you will get point of intersection. Now, what is that trick? Let us call this equation as E. Let us call this equation as E. So del E by del X is equal to 0. Apply partial derivatives on E. Apply del E by del Y equal to 0. The proof we can do in ellipse, some other chapter, not this chapter. In this chapter, you will not be able to understand because you haven't done ellipse, hyperbola, any other chapter. Now, what happens when you apply del E by del X equal to 0? You get a line. And when you apply del E by del Y equal to 0, you get another line. So, two lines are obtained. These two are not the lines that form this E. These two are not the lines that form this E, but their point of intersection is gives alpha and beta. Ye, just note this down very properly. Beware. Line 1 and line 2 are not the original lines, but their point of intersection are not the original lines. But the point of intersection still gives the same. What do these lines represent? We will discuss soon in conics class, but not right now. This is slightly faster. Let us apply it in one question and see how it works. Let us apply it in one question and see how it works. Okay. Okay. So see, look at this pair. We separated it yesterday, right? Let us find its center. How? Let's differentiate. Let's call this thing E. So del E by del X. A lot of people who don't know what is partial derivative, it is simply differentiating with respect to X. It is simply differentiating with respect to X. Keeping Y as constant. So this becomes 2X plus 3Y plus 0 because Y is a constant plus 2 plus 0 plus 0 equal to 0. That is the first one. Yes, Akhilesh, you can join. Which gives us 2x plus 3y plus 2 equal to 0. Now what about del E by del Y equal to 0? It is 3x plus 4y 0 plus 3x plus 4y plus 0 plus 3 plus 0 equal to 0, which gives 3x plus 4y plus 3 equal to 0. Now these are not the lines that formed that. If you will multiply them, you will not get the original equation. If you will multiply them, you will not get the original equation. Now one child has asked a very good doubt. How will you define center for an ellipse in limiting case? I feel that this discussion is beyond the scope of YouTube. If you want, you can discuss in my lectures that happen on Unacademy. Why are line 1 and line 2 not original? Because these equations solve different purposes. They are not meant to factorize the original lines. But you solve both of them. You solve them. You will get minus 1 comma 0, which is the center. So definition of center and why this works, what are these lines, all these things are very awesome. And I would love to discuss them, but not here or right now. Because then we will not be able to move further with the chapter. What actually happens in this case, they are not even angle bisectors. If you start feeling that they are angle bisectors or something, no. These are suppose the original lines. These are some of these two lines. This is what it happens. So they meet at the same point. Yeah, might be on Unacademy, Shivam. Okay, but there is a danger in this method. There is a danger in this method. What is that danger? Suppose look at this equation. So this is not a pair of straight line. This is not a pair of straight line. But still, if someone tricks you, find the point of intersection, you will apply. Yes, I will find point of intersection. This is E. You will do this. And in this question also, what will happen? You will get the same answer. You will say this is minus 1 comma 0. Yay, we got the point of intersection. While that is not true, this is not even a pair of straight line. This is not even a pair of straight line. So this method gives you center. To ensure that the original equation is a pair of straight line, that is your job. This is what it can do. This is what it can do. What what JEE paper setter can do if it wants. It can give you an equation which is not a pair of straight line and ask you to find point of intersection. People will apply partial derivatives and right answer, and then JEE will say आपको बकरा बनाया गया है, कैमरा उधर है, हाथ हिलाइए. So there is that danger. But if the options doesn't have none of these, and you know answer will surely come, JEE will not trick us like that. It is a very cheap. It is very cheap trick. It is very cheap trick, but well played. So ideally, this curve must be some other curve. Might be an ellipse or a hyperbola or whatever. It must be some other curve. Okay, just copy this down, guys. Any other signature left? Show me, I'll do. Okay, guys. Apologies. Okay, but still, this method is cool. Why? Do you know what this method can do? This method can also check. Can also check an equation is a pair of straight line or not. I'll tell you why and how. See this. This is a fraud answer, right? This is a fraud answer. So it must be some other curve. It must be some other curve. And we have treated it like pair of straight line. It is not actually a pair of straight line. It is some other curve. It might be circle, ellipse, hyperbola, something else. Now, out of all the curves which have center, we are very sure that it is not a parabola. Because if it was parabola, you wouldn't have got any answer. Because parabola does not have a center. We are very sure that it's not a parabola. It's surely not a parabola. But how to check whether it's a pair of straight line or not? I'll tell you why. Just see that out of all the centers we have, only pair of straight line center lies on the curve. Rest of them either inside, here, outside, whatever. Only pair of straight line center lies on the curve. Only pair of straight line lies on the curve. So substitute minus 1 comma 0 and see if it satisfies. Substitute minus 1 comma 0 here and see if it satisfies. If it satisfies, then it's correct. If it does not, it's not pair of straight line, it's a fraud answer. So 1 plus 0 plus 0 minus 2 plus 0 plus 2. No, does not satisfy. Cool, right? So using this method also you can check. Using this method you can check. Do you know what happens if suppose you understood? Using this method also you can check. If the obtained answer satisfies the original equation, then it's okay. Because in the other curves, this point does not lie on the curve. Right? You understood? Everybody understood this? Yeah. This is a cool method. Actually, if you apply this method generally, like suppose this is your pair of straight line. Suppose this is your pair of straight line. If partial derivative gives 0, 0, it is actually a pair of straight line because what? Partial derivative gives 0, 0 and it satisfies or not? Anand. Partial derivative can give 0, 0. That does not mean that it is a pair of straight line. I'll explain. Wait. Suppose this is a big pair and then you apply partial derivatives. You apply partial derivative. Then you solve. Then you solve them, you get some answer. Now what happens if you put that answer, here, if you put that answer here and you get 0, it must be a pair of straight line, right? If you put that answer here and it becomes 0, then it must be a pair of straight line, right? If you put that answer here and it becomes 0, it must be a pair of straight line. Yes or no? Do you know what comes when you put the answer there? This thing. This thing comes. If you put this answer here, it becomes this thing, whole thing becomes delta and you will get delta equal to 0. So you have found out another way to derive delta equal. It gives you delta. You can try at home. You can find that bad looking answer and substitute it. It will simplify and it will give you delta. It will give you delta. The whole thing has come around in a circle. Is everybody clear till here? Yeah. Maths is fun. Coordinate geometry is super fun. You can try it. You can try. I tested it when I was a kid. I tested it. I didn't believe it. So I got a very bad looking answer, and after 1 hour, I substituted it and got the answer. I found out delta. I was very happy. I found out a new method to derive delta. Sumit, basically this will give you the center, and if we apply the condition that center lies on the curve, center satisfies the original equation, we are essentially forcing this equation to become a pair of straight line. So it should give us the condition of pair of straight line, which is delta equal to 0, and it happens. If you find the point of intersection and substitute it here, you will get big expression which ultimately becomes delta. So you will get delta equal to 0. Sumit, is this okay? Sumit, is this okay? Clear, Sumit? Great. Awesome. Now, there is one more beautiful thing about big pair and small pair. Look at this. This is a small pair. This is a small pair. And this is a big pair. This is small pair. Suppose this is a small pair and then there is a big pair. Some cards have also come. Yeah. Some courier, etc. is coming before birthday. Yeah. That has happened. And the courier guy is saying, no, you only have to sign. I can't go. Yeah. You're right. You guessed it right. Okay. So now, when you factorize it, you got this. Okay. And when you factorize this one, you get this. Yes. We will enjoy this birthday together on YouTube. God knows. God knows. Okay. So now see, focus on these three terms. They are identical, right? Samarth, for 3D, wait. For 3D, wait. You don't know a lot about 3D. Linear equations are not lines in 3D. Any linear equation in 3D is not a line. It's a plane. So there will be a lot more different things that happen there. Okay. So now see, can you see that first three terms are same for these two? And how has it impacted the two lines? First three terms, that means 2 degree terms are same. Yes or no? 2 degree terms are same. Can you see? Take one more. Take one more. Take one more. Look at this one. If you factorize this, you will get this. You will get this. People are asking, how are you factorizing so quickly? I am not factorizing. I already know that what do they get after factorization. I am not factorizing. I'm just, I already know. I am the one who is multiplying them. Observe, observe very carefully. What is the impact created by first three terms same? See, their slopes come out to be the same. Slopes are same. So what happens if first three terms are identical in two pairs? If first three terms are identical in two pairs, that means their shape is essentially the same. They just get shifted to different places. Their shape is the same. Their slopes are same. Yes, 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 yes. They have the same slope. It's like, what are the slopes here? Minus half and minus 1. So this is M1, this is M2. The slopes come out to be same. Only their locations change. So if two pairs, no matter big or small equation, if two pairs have 2-degree terms identical to each other, they both have same 2-degree terms, that simply means that their shape, their slopes will be same. Only their locations will change. One of them might be formed at origin, other at some other point, other at some other point. And that point you can find simply by partial derivative. That point you can find simply by partial derivative. Will give location. So we will come to a very cool funda now. Can I turn the page? We will come to a very cool funda now. Can I turn the page? So if ax square plus b plus 2hxy plus by square equal to 0 is a pair of straight line, then do you understand this? Then a x minus alpha whole square plus twice h times x minus alpha y minus beta plus b times y minus beta whole square equal to 0 is also a pair of straight line, having same slope as original, having same slope as original, but location alpha comma beta. Yes or no? It is almost like same thing. This is a circle which is formed at origin. What will this be? Replacing x by x minus alpha. This is another circle. Again the same shape, same size, everything. Just this is formed at 0 comma 0. This is formed at 0 comma 0 and this is formed at alpha comma beta. Similarly, this is formed at 0 comma 0. and this will be formed at alpha comma beta. If you expand this one, you will find coefficient of x square matches. See, ax square matches with ax. Coefficient of y square also matches by square. See, and coefficient of xy also matches 2hxy. And it should match. It should match. Why should it not match? Because after all, it's the same shape and size, everything. It is just the location is different. It should match. Is everybody okay, comfortable till here? So let me give you a question. Nice, cool question. Huh? This came in the test of a coaching class whose name starts with N. Solve it. Guys, how to find lambda? How to find lambda? How to find lambda? How to find lambda? No. Lambda we can find by putting delta equal to 0. Lambda we can find by putting delta equal to 0. Apply delta equal to 0 to get lambda. But why? But why? Do you need lambda? We don't need. We only need these three terms. So this is all garbage. You don't even need it. Start with this one. This is formed at origin. And this at 2 comma 5. Done. You don't need lambda. Those of you who are saying that I'll put 2 comma 5 here and then find lambda, have you ensured that after putting 2 comma 5 here, it is a pair of straight line? How can you assume that at 2 comma 5 center that these terms will be 13 and 11 only? That you can't assume. Right? It might give some other curve where 2 comma 5 is not even the center. It just passes through 2 comma 5. If you put 2 comma 5 here and find lambda, it will give you some other curve which will pass through 2 comma 5, but 2 comma 5 won't be its center. Has everybody understood this? Yes, class. You can find delta equal to 0 and then find lambda, but you don't need it in this question. It's not needed. Okay, let's do one more question. Cool question. Let's do one more cool question. Do it now. Should I repeat? Okay. This is a big pair. It must be formed at certain location. But what about this one? This light blue one? This is same shape as this one, but it is formed at origin. Once you reach origin, then you can apply this funda. Then you can apply this funda. Remember, to apply this funda of shifting, you need to be at origin first. In the original, you cannot apply this funda that everywhere you replace x by x minus 2y minus 5. That is not okay. You first have to come to origin and then apply this funda. What is the use of same slope? Since these three terms are identical, you will have same slopes. Who said terms of G, F and C disappeared? Come on. Expand it. You will get an x term, you will get a y term, you will get a constant. You expand it. We have just not expanded it, that's all. Expand it. Those of you who are thinking that G, F and C vanished here, try and expand it. X square minus 6xy plus 2y square. Now how many? Minus 4 times x plus 30 times x. So plus 26x minus 20y plus 12y minus 8y. 4 plus 4 plus 5 2s are 10. 4 minus 60 is minus 56. plus 50 is minus 6. Who said they vanished? This is the answer. If you want to expand it. Understood? So don't, who said G, F and C vanished? They are just there. We haven't written it in that form. So remember, to apply this funda, you first have to reach origin. That is crucial, and then you can shift. Now what to do? This time the slopes are not same as the original. Slopes have become double. What to do? After definite, we will do area under curve and differential equation, and then application of derivatives. No, no. So when, how to play with slopes? Write down this heading. How to play with slopes. If suppose it starts changing the slope, then how to play? So first of all, let me introduce something called slope quadratic. Slope quadratic. Okay, Manopriyo. Now what is this quadratic? It's a quadratic whose roots are pair of straight lines, are slopes of pair of straight. It's very easy to find out. In fact, it's so easy, we will learn the answer. So for ax square plus 2hxy plus by square plus something something x plus something something y plus constant equal to 0. Why am I writing it like this, something something? Because it can be either bada pair or chota pair. If the slopes are m1 and m2, if the slopes are m1 and m2, if the slopes are m1 and m2, do you understand this? M1 plus M2 is minus 2h by b. And M1, M2 is a by b. Right? So you have sum of the roots and product of the roots. The quadratic that you want to find. So that quadratic will be m square minus sum of the roots plus product. Yes or no? Yuvraj, I am trying my best in maths, but due to poor basics, I am losing my confidence in maths. JEE. Message me on TG. Let me see what part is weak, what minimum portion you want to do, or find some place where you can finish backlog. So this is m square minus sum of the roots is minus 2h by b. You will have to decide what bare minimum you can do. You cannot do everything. When you have backlog or poor basics, then you will have to choose. And product is a by b. So you get, so for big pair, or small pair, this is slope quadrant. Learn it. Direct formula. We have a direct formula. PP. Okay. Noted? Okay, so suppose you have pair of straight line. You want to make it convert it to slope quadratic. You have direct formula, direct result. But how to convert slope quadratic to pair of straight line? How to come, how to apply reverse gear? Suppose this is given. How to reach from here to here? How to reach from here to here? How to reach from here to here? Let me tell you. See, you already have quadratic in slopes, right? So this is, let's say, m1. So you want locus of this x comma y, right? And this point is, let's say, alpha comma beta. This point is, let's say, alpha comma beta. You want locus of this point x comma y. Do you realize y minus beta upon x minus alpha is the slope? So instead of slope, replace m by y minus beta upon x minus alpha. How slope quadratic is helpful in solving questions? We will understand that in next 15 minutes. So from pair of straight line, you can get slope quadratic. From slope quadratic, you can get pair of straight line. That you can keep on doing. Now let us come to the original question. So from here to here, you have direct formula. Now see, that was the question, that find the equation of a pair having slopes twice. That was the question, right? Twice the slopes of and having point of intersection at 2 comma 6. This was the question, right? Correct. What to do now? What to do now? So this is the original slope quadratic. Try to pay some attention, then probably you will get feel. If the quality of content cannot give you feel, then probably you are in the wrong place. Okay, now see, this is the slope quadratic, original. Huh? This is the original. How to get new slope quadratic for the new pair? This is the new pair, right? How to get new slope quadratic? See, of course, the slopes are m1 and m2, but the new equation will have slopes as 2m1 and 2m2, right? From master music, only little bit limits is required. Roots want to be double. of the original. How many of you remember quadratic chapter where you have to replace? Do you remember this concept? Replace m by m by 2 and the roots will get doubled. Replace m by m by 2. This you must have studied in quadratic. You must have studied in quadratic. Do you remember this? Replace m by m by 2. Now some people will not remember this and they'll definitely feel and they will definitely curse the chapter. Either the chapter is bad or the medium of conversation is bad or the platform of YouTube is bad. But they will never blame that they themselves are bad. That when the whole world was studying quadratic, they were not studying. So people will blame many things. Chapter is bad, timing is bad, it's night time, so I'm sleepy. Platform is bad, YouTube is not a place to study. The language, the way of conversation is bad because sir is not teaching his English. He's not roasting. I won't roast. But they will not blame the truth. Okay. But this is the new slope quadratic. We do not want slope quadratic, new slope quadratic. What do we want? What do we want? We want new equation. How to find new equation? Tell me. How to find new equation? Replace m by y minus 6 upon x minus 2. And this is your answer. If you want to take LCM, etc., you will get that big equation. If you want to take LCM, you will get that big equation. But no need to take LCM, leave it like that only. No need to take LCM, you can leave it like that only. Those of you who get extra marks, of you who get extra marks after solving, can solve. m by 2 की जगह 2m कर दिया. नहीं. You will have to, in the transformation, you have to substitute the inverse one. So if you have to make the roots 2m, so you have to replace m by 2. If you have to make roots m plus 1, so you will have to replace m minus 1. You have to put the inverse here. Okay, let me give you one more question. Should I give you one more question? Okay. Now see. Solve it. Yes. How to solve it now? How? Correct, Vaibhav. That also you can do. Or you can directly say that this is the original slope quadratic. Original with roots m1 and m2. So new wants to have roots -1 by m1 and -1 by m2. Now those of you who haven't studied quadratic will wonder how we are substituting. So please revise quadratic. Actually, you don't even need this transformation thing here. You can use sum of the roots and product of the roots. That original sum is -2h by b. Original product is a by b. So we need new sum, new product. We can create new quadratic. So by the long root also you can create a new quadratic. Question is very simple. It is giving you old roots. It is saying I'm changing the roots, now create the new quadratic. These type of questions you can done in class 10th also. The transformation is simply a faster way of doing that. Transformation is simply a faster way of doing that. You can do the same questions by class 10th method. New sum of roots, new product of roots you can find, and then you can proceed. So this is the new slope quadratic, which is this is the new quadratic. But do we need new quadratic or we need the new pair? So within one line we can find the pair. This is the new pair. And this is the new pair here. If you want to take LCM, you can take LCM, etc. But this is enough. So whenever it wants to play with the slope, slope quadratic is very helpful. Those of you who are not comfortable with this transformation thing, na, they don't need to worry. You can find the same thing with class 10th and 8th, 9th, 10th method when you were studying quadratic. The teacher used to give those questions. Na? The original quadratic has roots alpha and beta. Now create a quadratic with roots minus 1 by alpha and minus 1 by beta. So you used to create new sum of the roots minus 1 by alpha plus minus 1 by beta and new product of the roots, and then you could create the quadratic. That also you can do, but it is just a longer way of reaching here. You will reach here only, but just in a long way. Transformation is faster and it's studied in class 11th quadratic here. So you don't actually need transformation. Transformation is just the quadratic equations part. You don't need it, but that's okay. Is everybody okay here? Comfortable? There is one result that you can remember. There is one result you can remember. This is the original pair. And look at this. The new pair, if you interchange these coefficients, so like make it bx square, ay square, minus 2hxy is equal to 0. And make this one as negative. Then you get perpendicular pair, perpendicular to original. This is something that you can learn. Perpendicular to original means, I'll show you. Interchange, put it here, and just make it this negative. Suppose this is your original pair. I'll draw it in blue. This is your original pair, suppose. So this green one will be the new pair. You will see that this angle is 90 and this angle is also. Okay. Is everybody comfortable till here? Yes, yes, yes. I'll tell him for the tell my team for the DPP. Okay, so send the DPP to the YouTube description link also. Make sure it covers only what we have done in class, because still portion of pair of statements like homogenization and other things are left. So don't cover that. Just whatever we have covered, make a DPP on that and post it in the description, as well as the any straight lines course we have on Unacademy platform. Both places. Okay. Now solve this one. Came in test of one coaching class. whose name starts with C. Uh, it is applicable for big pair also, Sami. Just the other terms will come. Solve this one. Yes, yes, slides of lecture also, for sure. It's an easy question. Solve it. Yes, 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 yes. You can guess those names, but please solve the question. How? Again, he wants to play with the slopes. It is one of its favorite questions, playing with the slopes of this. So we'll start with slope quadratic. So the slopes are, let's say, m1 and let's call the slopes as alpha and n alpha. No, no, no. Slope of one of the lines represents by this be the nth power of the other. Alpha and alpha raised to power n. Alpha and alpha raised to power n. These are the slopes. So this is the relation that we have. Alpha plus alpha raised to power n is minus 2h by m, and alpha raised to power n into alpha is a by b. These are the two relations that we have. What to do now? Since there is power 1 by n plus 1, it gives us the hint that we should take power 1 by n plus 1 somewhere. So alpha comes out to be a by b raised to power 1 by n plus 1. What should I do? I got alpha now. What to do now? Tell me. Simple. Alpha satisfies this. So let's put it here. Very good. Very good, Anant Shukla. So we'll put alpha here. A by b raised to power 2 by n plus 1 plus 2hm, which is a by b raised to power n plus 1, 1 by n plus 1, plus a equal to 0. So we'll have to then simplify and all that, but we will get the answer for sure. Easy, comfortable. You realize if there is slopes, now you should play. If the question wants to play with slopes, then slope quadratic is very good because it immediately converts the whole question to the quadratic question. And we have studied quadratic well enough. We have studied quadratic well enough, at least more than pair of straight lines. So it is much better to go to quadratic rather than keeping the question in pair of straight lines. Does this make sense? What I'm trying to say? Yo kids, not simplified. Let's leave it like that. We can simplify. Doable? Doable? Okay, let's move to the next question. Slope quadratic is very good when the question needs slopes or plays with the slopes, but it is not useful in any other scenario. Let's solve this question. Very good question, present in A. Das Gupta book. Very good question. Easy but present in eras. Let's solve this one. Sumit, this is YouTube. Those of you who want chutti can go for chutti. Those of you who want to do, so what to do? Should we do general discussion? Do you want to do general discussion? Okay, after two questions, we'll do general discussion of preparation and everything else. Okay, how to solve this one? How to solve this one? How to solve this one? Do you understand what he is saying in the question? See, this is a chota pair. So it must be formed at origin. So there must be a circle having center at origin. Why? Because both these lines are along the diameters, right? So their point of intersection must be the center. So like this. Now the area is, one of the sectors is thrice the area of the other. So this area is thrice of this one. What to do now? This is thrice the area of this one. What to do? See, obviously this is theta. This is 180 minus theta. So area theta r square by 2 is 1 by third of 180 degree minus theta r square by 2. Area. Yes, 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 yes. So r square gets cancelled, 2 gets cancelled. I should have taken in radian, but that's okay. Won't matter in this question. So 3 theta is 180 minus theta. So theta comes out to be 45 degrees. So that means this angle is 45 degrees. So just ensure that this angle is 45 degrees. That's all. How to ensure that this angle is 45 degrees for this pair of straight lines? Tell me how to ensure this angle is 45 degrees. Tell me. Simple. Tan theta should be 1. Tan theta should be 1. So 2 root h, which is a plus b whole square, minus ab upon a plus b is equal to 1. Now you can square it. You can. Cool, right? Yes or no? Yes or no? Okay. Now try this one. Okay, there are two results that I don't want you to derive, just remember them. These are two important results. I don't want you to derive, just remember them. Result number one. Suppose you have two parallel lines. Suppose you have two parallel lines. Okay. Pair of parallel lines. Okay. So now what happens? Naturally, people will ask you how to find distance between these two parallel lines. This distance d. Naturally, people will ask that, right? So, what is the there is one way you separate out two lines and then apply the formula. If you have two separate lines, then you can apply the formula C1 minus C2 upon root of a square plus b square. That can work. That can easily work for sure. However, however, you need separating two lines, which is not easy. So there is a direct result also. Note down this result: 2 root g square minus ac upon a into a plus b, or both of them give the same answer: 2 root f square minus bc upon b into a plus b. You don't need to derive it. You can derive it, but no need. Just learn it. So this is one result which gives you distance between two parallel lines without separation. Raina, that area of sector theta upon 360 degree into pi r square. So this is one result that you should remember. We can derive it if we get chance. We can derive it in some plus lecture or special lecture on Unacademy. On YouTube, it's not required derivation. And similarly, there is one more result. Result 2. No, this is not original. This is present almost everywhere. But the way I prove it is very original. The way I prove it is very original. But we don't need proof here, so let's proceed. Okay, result 2 is, suppose you have two pair of straight lines, which is the small pair, which is this. Now you very well know you can separate these two and then find the bisectors, angle bisectors. These are the angle bisectors. And since angle bisectors are 2, so there is khujli in people, since these are 2, let's multiply them and get their pair also. So angle bisector pair is obtained by this. Directly learn this. You don't need to derive. You don't need to separate and then multiply and get this result. You can directly remember it. This is the pair of angle bisectors. Yes, they will be perpendicular. Check. Coefficient of x square plus coefficient of y square is 0. They must be perpendicular. Yes. Coefficient of x square plus coefficient of y square is 0. They must be perpendicular for sure. Yes. A plus b equal to 0, right? What is a here? Here, this h is a. Here, minus h is b. So a plus b is 0 for this pair. So yes, they are perpendicular for sure. You can derive it, but I don't think it's required to derive it on YouTube. Clear? Yes, this is the pair of angle bisectors. This is the last question for the day. Solve it. Then we can move towards strategy. Don't worry. The first one is very easy. There is direct result. H, which is 2x square minus y square, is equal to a minus b xy, which is 2x square plus xy minus 2y square equal to 0. Answer. So first one is very easy. First one is of course very easy. Now let's talk about the second one. How? We don't have direct formula. Think. Think. We don't have direct formula. So everybody is very intelligent. They have found the solution. The solution is same. So it will look almost like this, just with a single twist. It will not be formed at origin because this pair 1 and pair 2 are almost identical, just formed at different locations. So even angle bisectors must be almost identical, but they will be formed at different locations. So we need different location. We need this point alpha comma beta. No, 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 no. Lambda is useless here. You actually don't even need lambda. You don't even need lambda. You just need that alpha and beta. You just need that alpha and beta. Find alpha and beta. Find alpha and beta. To find alpha and beta, you won't need lambda. I think you should get this answer. So guys, how's the Josh? No, we don't need to. We don't need to. This is surely a pair of straight line. This one. This is surely a pair of straight line because it is obtained by shifting a small pair. The second one, lambda will automatically take such a value that it becomes a pair of straight line. If you will ensure the second equation is a pair of straight line, you will just find lambda. Is the question asking lambda? No. So how's the Josh? Hi. You want some strategy now? Some strategy? Okay, let's go to strategy. Tell me, what are your strategy doubts? Thanks, Anant. Thanks. Same to you. Yeah, tell me. What are your strategy related doubts? How to study 30 hours in a day? How to study smiley banta hai 30 hours. So many people ask me this question. Why? How is it possible? Well, why do people ask me this question? I don't know. How is it even possible? Why do people ask it? I don't know. So, if in a day I feel that they ask me that they want to study 30 hours, is because they probably want more output from their study. To get more output, you have to understand that how much of an output is required in a day to crack IIT JEE when you are in class 11th, let's say. So outputs 11th, 12th, 13th, and backlogger. There are four categories. Okay? Even a YouTube video has been made on this topic by two legend fellows. Oh, they must be telling how to increase the output here. Must not be. 13/14. Okay. Now look at this. Now this is lecture and self-study. So lecture includes coaching, everything and all that. Actually, we are talking about self-study time. Lecture timing is separate. You can attend lectures whole day. You don't even need to measure lecture hours. It can be more, it can be less. Let us measure only self-study hours. Okay, let's measure that. So for 11th, you should be able to get around 5 hours daily. 5 is good number. 5 hours. And if you are able to maintain this 5 hours daily for the next 2 years, now you will go through. You will clear. This is more than enough. If you are in 11th and you don't have any backlog or anything, right from the month of, let's say, June or June, July, you have started studying regularly. You are not missing any lecture. You do homework daily and all that. 5 hours daily, if you do self study from 11th till the end, that's more than enough. But suppose you are in 12th now and you haven't studied properly in class 11th, and you feel that you need to push a little more. You have to reach now 6 to 6.5, 6.5 hours, and that ultimately depends on how much backlog or anything you have. Okay, so it depends. Suppose you are in class 12. So all of, if anybody is in class 12th right now and they have backlog of 2 chapters or 3 chapters, let's say 3 chapter backlog. This is with respect to 3 chapter backlog. If you have more backlog, na, but suppose you are in 13th and 14th and you have studied properly for 2 years. Now in 13th and 14th, there are two cases. 2 years used, 2 years wasted. So now if you have used 2 years already, that last 2 years you studied, at least 60% or 65, two-thirds of your syllabus is good. Two-thirds of your syllabus is good, let's say. Okay? So though so you have studied for 2 years, your two-thirds of your syllabus is good, one-third is not good, that's why you want to take a drop. You don't need to study more than 7 hours per day. But if you have wasted 2 years, then comes the issue. You will have to reach around 8 to 9 hours. And here is the problem. If you have wasted 2 years, now wasted 2 years means last 2 years you did not study at all. You only did, you don't even know board level. You are not even able to solve NCRT. That is 2 years wasted. That is 2 years wasted. But if you have studied last year, but you were not very serious, so what used to happen? You used to attend lectures, you did half of the DPPs, half of the assignments. So you have done half of them. You know things, but you don't have practice. The things are not clicking in exam. Those kind of things you have. Then 7 hours daily is enough. But you have wasted 2 years and there's a lot more backlog and you have to cover everything. Then 8 to 9 years, and let me tell you, it is still tough. It's not easy. So the whole issue of 30 hours in a day, I think it will be like for these people, for backlog Janta. But if you have prepared properly for the time, then I don't think this is very good. Even I didn't study for this much. I studied for max to max 5 hours daily. This was, and I started in 12th, and in my time it was subjective paper. Yet I cracked it. So understand. Also, let me give you some strategy for this Janta. Let me give you some strategy for this Janta. Do you want me to give strategy for this Janta? Is for this Janta, do you want me to give strategy? They have to prepare very smartly now. So this Janta who has backlog backlog plus drop plus uh, years wasted, not even NCRT, this Janta. So suppose you have reached here, you realize that you did not study properly, you were probably studying from YouTube. Sorry, we are also teaching on YouTube. But suppose you are studying from YouTube from some places where they do not deliver proper content, or there can be many reasons. Now, first of all, what you should do is, there are many students who ask me in my lectures what to do now, sir. I used to study there. Now I'm seeing your quality, it's different. And so, first of all, no blame game. No blame game. This is the first thing you have to do. Stop blaming anyone. Whatever happened, happened. हो गया, हो गया. I used to go for emotions wala lecture. Okay. I used to go for time pass lectures. Okay. I used to spend my time in reels. It was my mistake probably. Okay. Whatever happened, happened. Now, decide decide what's least important for you. For example, suppose you are not good with chemistry, and suppose in organic chemistry you are not able to solve, and it's very tough. You are not able to remember that, and it's very irritating for you. So you have to decide on what things you want to leave. So you'll have to prepare a list that if कुछ छोड़ना पड़ा, if by chance if I have to leave something, this is the first thing I can leave, this is the second thing I can leave, this is the third thing I can leave. Prepare a list. I'm not saying that you should leave. I'm saying that you should create such a list that I'll leave this, I'll leave this. So when I wasted my whole 11th, I also created this leave list. And I first thing that I put here was inorganic. It was because of the way I used to study. I tried learning inorganic, I could not learn. I tried understanding inorganic, I could not understand. I tried reading the books, I could not. So I decided probably I am not made for inorganic. It is something which is much higher than my mental level. So I left it. What else did I leave? What else did I leave? I left some high level books that a lot of students used to boast about. So in my time, there was a book called Tata McGraw-Hill, and it used to have good questions. Actually, those questions were not good, but the coaching was not up to that level that you could deal with those questions. So whenever you used to open that book, it was always a confidence shatter. So it was always used to shatter your confidence. So what I decided I will not do this book. Imagine, I teach you maths, but during my JEE preparation, I decided I will not do Tata Macro book. Today, I laugh at that book. That it's not even tough. But that time I decided. What did I do then? I used my coaching notes and assignments and everything and kept on doing. Some extra assignments from here and there. I kept on doing. I make sure that I did very targeted practice. For example, if I study, let's say, integration. Now, everything is clear in integration to me. Only the places where they apply, let's say, substitution is not clear. So I prepared the assignment based on only on substitution. Very targeted practice I used to do. I didn't waste time that I'll do whole book. Suppose you ask the teacher that, sir, everything is good in coordinate geometry, but in straight lines, the locus questions are not good. I'm not able to solve. So the teachers used to give me this whole book, solve this book. Now that book has so many questions. I used to keep on searching where are the locus questions. So much time waste. Instead, I found out someone who prepared an assignment only on locus questions for me. So he used to give me some 10, 11 questions and I used to practice those. So I did very targeted practice. So I ditched all high level books and all that. There was another high level book I ditched. Someone told me that there is a book called Morrison Boyd. It is very good for organic. If you study organic from Morrison Boyd, you can even win Nobel Prize. We were idiots. People used to make us idiots. We were big idiots. Okay, so someone told me that if you study Morrison Boyd, you can even win Nobel Prize one day. So I bought that Morrison Boyd book. It's such a thick book. And it was very interesting. Every page, beautiful diagrams of molecules, this and that. It looks very interesting. It wasted my 10 days. But then I came to my senses. I realized not up to my auqat. I cannot do it. So I left that book also. What did I do in organic then? My coaching notes, assignments, and I was not that good with organic also, but only. There was one more book that was very famous that time, Kurutov. Kurutov was famous, but there was something called Kurutov also, and that book was not easily available. Its Xeroxes were available in many places. So now there were students who used to solve Kurutov. There were students who used to solve Kurutov. They were not able to solve, trust me. They were not able to solve. In 2002, 2000, people were not that intelligent. They were not able to solve. They used to boast that I solved. And with that boasting, they used to create tension in the other. But I decided I will not be able to solve Kurutov. So I limited myself to HC Verma and Erudov. And Erudov only selected problems. So I limited myself because I realized that this is only how much I can do. So that is, you have to prepare your leave list. So this kind of list, if you decide, then you will have some tension-free mind. Third thing is this: leave for later. Now, what does this mean for later? What does this mean for later? Leave for later. What is for later? I'll tell you what is for later. We are in the month of October now. Okay, September is almost ending. October is coming. Now you feel panic about your backlog. What to do? Suppose you have 5 chapters back. All 5 you cannot finish in October. You can finish only one of them. So when my full 11th was backlog, I divided 2 chapters of 11th in February, 2 in March, 3 in April. I divided like this and I kept on pushing things for later. I was not able to finish full backlog. I was able to finish only 60 to 70% of my backlog. But I kept on doing and I planned every month like this so that my interest was maintained. Otherwise, your interest goes for a toss. You start hating padai. So push things for later and उसमें से थोड़ा करते. For example, if your quadratic is a backlog, today you got to know that your quadratic is backlog. So it's this month decide I will do quadratic and 1 chapter of physics backlog cover. That is all I can do in October. Rest I will do in November. Rest I will do in December. And also don't worry. Most probably January won't be JEE mains. If January was JEE mains, they would have started preparing and form fillings and all those things and also announcements would have started. But they are not. So I feel the JEE will be in the month of April. And even though if JEE comes in the month of January, let's say, then there will be 3 attempts, not 2. So January JEE should not make you feel panic. It should not panic you that January JEE has come and now what I'll do, I'll tension. Please like the session. Come on, guys. You understood? So this is what the planning is. This is what you can do. And you have to now understand your limits. Stop daydreaming. You have to leave this thing. And this is the, I'm writing it in red, daydream. I'll tell you what is daydreaming. 2 साल बिल्कुल पढ़ाई नहीं करी, कोई बात नहीं, अब आया हूं मैं, now I have come, I have started studying from August, yeah, or September, I will crack top 100 rank. Relax, let's be realistic. You, if you are able to crack, then you can crack, but that you cannot aim for it now. You'll have to be very realistic with your aim. Stop daydreaming. Plan things properly, this and that. Things will work out if they have to, and at least aim for something reasonable that you can achieve. For example, for example, for example, even for advance, JEE Advanced, do you realize that out of 360 marks, let's say, if you score 180 marks, you'll reach IIT and you will reach IIT Chemical at least. You know that? So think about this, 50% of marks will take you to IIT. Your top 100 is obtained by 70% marks. What is 70% marks? 36 into 3 by 4 is 75. No? So 9 is 270. 270 upon 360 is your top 100 rank. So have some realistic target. You want an IITian tag? You want an IITian tag? So 40% is 140 marks out of 360. No, even lesser than that. Actually 120, probably 120 around, 120 or this data you can check. Will make you an IITian. It can be a pseudo IITian. You will go to some IIT Jammu or some place, but you will be an IIT. So to be an IITian, you have to score 1/3 marks. You'll get some branch. It could be lower than that also. It can be lower than that also. But this is what the level of advance is. So why are you scared? Just decide what you can do well and do that. In fact, let me tell you, if you prepare, some people think that if you prepare 50% syllabus, then your marks will be 50%. No, it will be more than 50%. Why? In the paper, you know only half of the questions you can solve. You will pick those questions and you will solve. You will get more time. You will do less mistake and you can solve them. So it's not like this that you have to do everything if you have backlog. Is everybody okay? I hope everybody understood. Okay, guys, let's depart. Let's be happy, enjoy. क्या पता आगे मिले ना मिले. Have fun, take care. Okay, take care, guys. Enjoy. Monoprios, sometimes log table is allowed, sometimes not allowed. There have been JEE Advanced where log table is not allowed. There have been JEE where they have given log table. Okay, guys. Take care. Enjoy. Bye bye.